Hello.
Hello, sir.
Yeah. Have you been working on functions chapter?
Yes, sir.
Do you have any doubts?
Right now, no, sir.
Okay. So if you don't have doubts, we'll do some questions then. The first question
Yes, sir.
is find the domain of this function f of x is equal to here the square bracket represents GIF, and obviously the normal this means mod.
Yes.
You have to find the domain of this function.
Sir, the domain will be from 17 to infinity union minus infinity to minus 70.
Why? Tell me why.
And what, sir?
Why is that? Explain why.
Sir, because the 1 upon root that should be positive under that root. Means
Mm-hmm.
mod x minus 5 greater, that should be greater than 0.
Mm-hmm.
And that should also not equal to 0 at that time. So in that case, only greater than 0. So we will do 11 there. So that now assuming mod x minus 5 to be a, so a greatest integer of a should be greater than 0, greater than 11. So
We like this,
yes,
right?
yes,
Because it is greater than 11, so it can take 12 is the next value.
yes,
So you're getting mod x is greater than equal to 17,
yes,
which means now x can be belonging to either 17 to infinity or minus infinity to minus 17. And
yes,
this is closed bracket here
yes,
because it can be equal to 17 or minus 17.
yes.
Okay, let's look at another question. Okay, so the question is this: let f of x let f of x be equal to x plus 1 and 2x plus 1 in these two cases, x plus 1 if x is less than equal to 1 and 2x plus 1 if 1 is less than x less than equal to 2. And g of x is also defined in a different way. So g of x is equal to x square and x plus 2. This is in this range. and x plus 2 is in the range 2 to 3. Now you have to find f of g of x. Find f of g of x, do the cases and figure out what it should be.
Yes.
I hope you're understanding what you have to do here.
Yes, sir. That g of x is a variable, so we have to draw the graph.
No, you don't need to draw the graph. You can do it without a graph also. You need to know how to do it. Nobody has asked you for the graph. F of g of x will be g of x plus 1 if g of x is less than equal to 1. And it will be 2g of x plus 1 if 1 is less than g of x less than equal to 2. Right?
Yes.
And now we have to think here, when will g of x be less than equal to 1? What are the possibilities? Right?
Yes.
So think about it. Can it be x plus 2?
No.
Because it can't be, because x plus 2 is only when x is between 2 to 3, right?
Yes.
That means x plus 2 will be greater than 4 actually, right?
Yes.
So the only possibility is this function could be g of x, right?
Hmm. Yes.
But if that function is g of x, you have to put the condition x square is less than equal to 1, right? From here.
Yes.
So
Hmm.
basically from minus 1 to 1, x should be between minus 1 to 1, right?
Yes.
So minus 1 is less than x is less than equal to 1. In that range, g of x will behave as x squared, right?
Yes.
And you will get x squared plus 1 here,
Mm.
correct?
Yes.
Similarly, now you have to think of the other option also. So
Yes.
basically, you have to think of this now. So now we have to think when is 1 to 2, g of x is between 1 to 2, right?
Yes.
Again, x plus 2 cannot be taken only
Yes.
because x plus 2 is output is between 4 to 5.
Mm.
So again, you have to do 1 is less than x square is less than equal to 2, right?
Yes.
So this will mean that it is bigger than 1 and less than root 2,
Mm.
right?
Yes.
And in that case, again, the function is 2x squared plus 1. Do you understand what I'm saying?
Yes, sir.
We are seeing that the other version of g of x is never used because it is never in this range. The only version of g of x that we were able to use is x squared, right?
Yes.
And we have already found f of g of x. It has two definitions. It
Mm.
is x squared plus 1 or 2x squared plus 1 from minus 1 to 1 and from 1 to root 2.
Yes.
You don't need to draw the graph. You need to think logically, clearly every step.
Yes.
Do you understand what I'm saying?
Yes, sir.
Okay, question 3. It is given that a polynomial function satisfies the following equation: f of x times f of 1 by x is equal to f of x plus f of 1 by x. And here, this is true for all x not equal to 0. And it is also given that f of 3 is equal to minus 26. You have to find the value of f of 4. Do you understand the question?
Yes, sir.
So try it out.
Yes.
Usually, polynomial functions are like this. This is a typical polynomial.
Yes.
Basically, looking at this equation, from this equation, you have to try to figure out what is the nature of this polynomial. Then only we can find out the values, right?
Yes.
So actually, see here, there are n plus 1 coefficients that are unknown, right?
Yes.
So apparently, this equation is enough for us to figure out those coefficients, correct?
Yes.
Without that, how can I find the value, right?
Yes.
This equation together with this.
Hmm.
So before we can do anything, we'll have to take f of 1 by x and see what is coming there. An by x power n plus an minus 1 by x power n minus 1, so on till a1 by x plus a naught, right?
Yes.
Okay. And then we will see what happens when you do fx times f of 1 by x, right?
Yes.
So if you notice, there will be one term an square, right?
Yes.
And there will be terms like an minus 1 square and a1 square till a0 square. All the squares are there. But there are many other terms also,
Yes.
right? You can see there will be terms like this x into an minus 1, right?
Yes.
There will be terms like x square into an minus 2, and so on, right? Do you understand?
Yes, sir.
Okay. And then basically there will even be a term x power n minus 1, an into a1, and x power n an into a0, right?
Yes.
And similarly, I have to do all the terms like this into this. Now see, there are terms of 1 by x power and all also.
Yes.
1 by x power and so on.
Hmm.
So f of x plus f of 1 by x, let's think of that also. That will become an common x power n plus 1 by x power n plus an minus 1 common x power n minus 1 plus 1 by x power n minus 1, right?
Yes.
And similarly, a1 common x plus 1 by x plus 2a naught, right?
Yes.
Now these two are supposed to be equal, correct?
Yes.
Okay. So think about it. If I had a term like this, an into an minus 1 x, I also have a term like an minus 1 into an 1 by x.
Hmm.
Do you understand?
Yes, sir.
I hope you are understanding what I'm saying.
Yes, sir.
There will also be a term like an minus 2 into an and 1 by x square. When you take x power n minus 2 here and multiply with this, right?
Yes.
So you can see that these terms will be grouped together. You will get x plus 1 by x
Hmm.
square into x plus 1, x square plus 1 by x square, and so on, right?
Yes.
Okay. So if you notice, when you compare the coefficients, the two polynomials are equal. So you can compare coefficients, right?
Yes.
So
Hmm.
let's compare the coefficients and see what we are getting. So first of all, if you compare the x term here, you're getting an minus 1, twice of it, right?
Yes.
Then you are getting x plus 1 by x here, right?
Yes.
Should be equal to, from this side you are getting a1, something like that, right?
Yes.
Do you understand what I'm saying?
Yes, sir.
Similarly, you're getting 2 times an minus 2 is equal to a2 because you
Yes.
get x square plus 1 by x square and all,
Yes.
right? And we
Yes.
are also getting similar terms, many terms like this will come, and then constant terms here are these in the
Hmm.
product, and here the constant term is this.
Yes.
So you're also getting an square plus an minus 1 square, so on till a1 square plus a naught square is equal to 2a naught, right?
Yes.
So you're getting many equations, right?
Yes.
Many equations are coming like this, many equations, and one equation for constant terms also.
Hmm.
Now think about it. We know the value of f3 is equal to minus 26,
Yes.
right?
Yes.
So technically, you have to try to guess what kind of polynomial it is and
Hmm.
how can we satisfy such equations, right?
Yes.
So it would be easier to do, like right now we have written a general equation. It would be easier to do if you try it out for a smaller degree polynomial.
Hmm.
Okay, so if you try it out for a cubic polynomial, for example, then you will get equations which are less complicated and then you can guess what is happening there. Okay.
Oh, yes, sir.
So right now, even though we have written the general equation, it is not easy to solve it. No, it's not obvious
Yeah.
here right now.
Hmm.
So let's think of a polynomial f of x. Let's say it was cubic. a3x3 plus a2x square plus a1x plus a0, right?
Yes.
F of 1 by x is equal to what? a3 by x3 plus a2 by x square plus a1 by x plus a0, right?
Yes.
And the product of these will become a3 square plus a2 square plus a1 square plus a0 square. This is the constant term. And then you
Yes.
have this multiplied by this. So a3, a2 power is x, right?
Yes.
Then a3, a1 x square and a3, a0 x cube, right?
Yes.
Plus a2 into this a2, a3 by x plus a2, a1 x, right?
Yes.
And a2, a0 x square
Hmm. Yes.
plus you're getting a1, a3 by x square plus a1, a2 by x plus a1, a0 x, right? And
Yes.
finally, you get a0, a3 by x cube plus a0, a2 by x square plus a0, a1 by x, right?
Yes.
So notice the pattern. You are getting x terms from where? From here,
Hmm.
from here, from here. Right. These are the x terms, right?
Yes.
A3, A2, and A2, A1, and A1, A0, right?
Easy. Yes.
And 1 by x terms will be similarly 3 terms, like this, and like this, right?
Yes.
Correct. So we are
Yes.
getting A2, A3, x plus 1 by x, plus A2, A1, again x here, and x plus 1 by x here also, right?
Hmm.
Plus A0, A1, x plus 1 by x here also. See,
Yes.
we are cancelling these terms now. We have already handled all of them, right?
Yes.
Then x square plus 1 by x square, you are getting here, here x square, here x square, here x square, and here 1 by x square. And there will be one more 1 by x square somewhere. These two
A,
and these two, right?
yes,
So you're
A3.
getting a3 a1 x square plus 1 by x square.
Yes,
So this is getting cancelled, this is getting cancelled, and similarly a2 a0 x square plus 1 by x square, right?
yes,
Correct.
yes,
And finally, there are two terms here left, these two, plus a3 a0 x cube plus 1 by x cube, right?
yes,
Okay. Now, and there is a constant term here. Now think
yes,
of what is f of x plus 1, f of 1 by x, f of
mm,
x plus f of 1 by x. So when you think of that, that will come out to be a3 x cube plus 1 by x cube
yes,
plus a2 x square plus 1 by x square plus a1 x plus 1 by x plus 2a naught, right?
yes,
If this polynomial that we have here is supposed to be equal to this polynomial, right?
ye-
We
yes,
will get equations like what? Like, first of all, the squares a3 square plus a2 square plus a1 square plus a0 square is equal to
two,
2a naught, right?
yes, mm,
Now, notice these three should add up to a3, right? a2 a3 plus a0 a1 plus a2 a1, right?
yes, sir.
Should add up to a3.
Sir, it will be A1 now?
Which one? Oh,
That
it will be
you,
a1, yeah. It will be a1, right?
yes,
Correct. Similarly, x square plus 1 by x square, these two terms, so a3 a1 plus a2 a0 should add up to a2, and finally a3 a0 should add up to a3, right?
yes,
So now the equations are a little easier here, right?
yes,
So we can say here that this implies either a3 is 0 or a0 is 1, right?
yes,
A3 is 0 will not consider because then our leading coefficient is 0. So then our assumption that it was cubic is gone, right?
yes,
So we'll not consider A3 to be 0. So we'll say A0 is 1, right?
yes,
Correct. So
yeah,
A0 is 1. And now see what happens because of that. If A0 is 1, so we are getting, notice here, this is 1. So A2 will
mm,
cancel A2. So you are getting
mm,
A3, A1 is 0, right?
yes,
Which implies A1 is 0,
yes,
right? So now we
yeah,
know A0 is 1 and we know A1 is 0, right?
yes,
So A1 is 0 means this term is gone, this term is gone, and this term is gone, right? And can you
yes,
see A2 is 0 now?
yes,
And A2 is 0, A1 is 0, A0 is 1. So this is 2 and A3 is coming as 1.
yes,
Do you see that A3 can be plus or minus 1?
yes, sir.
So notice that according to the conditions of the problem, if you assume the degree, we assume degree of 3, right?
Yes,
And you try to use the conditions of the problem, you're getting that all the terms other than the first and the last term are vanishing.
yes,
So you're getting the f of x will be, if it was a degree 3 polynomial, it is plus or minus 1 x cube plus 1, right?
yes,
Do you understand what we have gotten?
yes, sir.
In general, for n degree, it would have been something like this, plus or minus 1 x power n plus 1.
Yes,
Do you understand?
yes, sir.
Now, look at the conditions of the problem. They had given us f of 3 something, no?
Yes,
F of 3 was given as minus 26. So
mm,
that means that minus 26 is equal to plus or minus 1 into 3 cube 27 plus 1. So obviously it should be minus 1, right?
yes,
F of x should be minus x cube plus 1 then, right?
Yes.
And now f of 4 is easy. It is minus 256 plus 1, right? No, minus 64. 4 cube
63.
plus 1, right?
Yes.
Do you understand?
Yes, sir.
So this tells us one nice thing, and which you should remember because you don't have time to do the same steps every time. If you have a polynomial that satisfies this relation, right?
Yes.
If you have a polynomial that satisfies this functional equation, the polynomial is likely to be like this,
Okay.
right?
Yes.
We have basically solved it for the case n is equal to 3, the cubic case, right? You can
Yes.
even check it for biquadratic degree 4 polynomial, degree 5 polynomial. The proof for n degree polynomial will come by induction, and it is a slightly long proof. Okay.
Yes.
So, so right now we just need to understand this result. We have shown it for one case, and this result is valid in general. For example, if I had started off with a polynomial like x bar n plus 1, notice that if I add it, it would be like this. And if I multiply it, what is coming?
That will.
See, multiplication of this is giving this only, right?
Yes.
It clearly fits the pattern, right?
Yes.
Okay, let's move on to the next question then. Next one is this question 4. So it says f of x is a polynomial of degree 5, is a polynomial of degree 5 such that leading coefficient is 1, its leading coefficient is 1, and the values of some values are given. F of 1 is 5, f of 2 is 4, f of 3 is 3, f of 4 is 2, and f of 5 is 1. And what is f of 6? They're asking. Do you understand the problem?
Yes, sir.
Okay. See, there is a not so smart way to do it, and there is a smart way to do it. Okay.
Yes. Yes.
Don't do the not so smart way. The not so smart way is to try to find all the coefficients by equations.
Yes.
That is not what we are trying to do here. You have to think of a clever way, right?
Yes.
We know already the polynomial will look like this: x bar 5 plus a, x bar 4 plus b, x bar 3 plus c, x square plus dx plus e.
Yes.
But our job is not to put in equations and find a, b, c, d, e, right?
Yes.
So think of something better than that.
Yes, sir. Sir, would f of 6 will equal to 120?
1 second. Why? Tell me.
Sir, I just constructed the polynomial that's satisfying those conditions.
How?
Sir, that f of 1 is equal to 5. So, as the leading coefficient is 1, so so means x minus a, x minus b, x minus c, and plus 6 minus x.
You have to explain what you're doing properly. Give me reasons. Don't give me what you got.
Yes, sir. Sir, like the leading coefficient should be 1, so I can construct a polynomial like means I assume that its roots are a, b, c, d, and e.
Mm-hmm.
So the polynomial will look like x minus a, x minus b, x minus c, and x minus d, and x minus e.
Right.
Now that f of 1 is equal to 5.
Mm-hmm.
So if I means if I keep that a as supposed to be minus 1, that one root is minus 1.
How do you know?
Mm, 1 minute. No, sir. That means f of 1 is equal to 5 and degree is 5. So
Mm-hmm.
means I'm getting 6 minus x.
F of
Yes,
1
sir.
is equal to 5. So right now all we can do is put 1 here and say 5 is equal to 1 minus a and all, right? This is what you should get, no?
No, sir. Means f of x is equal to that and plus 6 minus x I have written.
Why?
Sir, because f of 1 5, f of 2 4 means they are decreasing. No.
You have written f of x as this plus 6 minus x.
Yes.
How do you know that? You have to explain, no? How?
Mm.
Why? Why did you write it like this? Earlier when you said this, you told me that a, b, c, d are the roots of the polynomial.
No, no, sorry, sir. I don't want to tell that it is the roots.
But then how can you write it then like that? See, you are on the right. I don't know from where you got the answer. Maybe you have seen the question like this before, but you are not able to explain it.
Yes, sir.
Answer कैसे है?
Sir, means I have solved this very much times. So, sir has told that the technique to solve this question means the one way is that you make the polynomial and put f of 1 is equal to 5 and make the equations and solve.
देखो,
And the
तुम
second,
ऐसा ऐसे तरीका से कर रहे हो. Sir has told the technique is good, but you have to understand, know what you're doing.
yes, sir.
बिना समझे कुछ भी टेक्निक लगा के आंसर लाना इज नॉट आवर पॉइंट.
Yes,
समझा तो नहीं पा रहे हो तुम, हिंदी में ही समझाओ. कैसे हो गई, कैसे हो गया अचानक? मुझे तो कुछ समझ में नहीं आ रहा. अगर अच्छे से तुम समझा पाते हो तो ग्रेट, लेकिन समझा तो पा नहीं रहे हो. बताओ कैसे समझाओ. टेल मी हाउ इट कम्स. You should be able to convince a ninth grade, 10th grade student of what you did. So far, what you have said is not very convincing. सोच के बताओ.
yes, sir.
यानी कोई आइडिया आ रहा है कैसे समझाने का?
सर एफ ऑफ एक्स 5 डिग्री वाला पॉलिनोमियल है जिसका लीडिंग कोएफिशिएंट 1 है।
हम्म।
तो सर एक वे है कि एक तो मतलब पॉलिनोमियल बनाए और फिर उसमें एफ ऑफ वन पुट करे तो कोएफिशिएंट मिलेंगे तो वो एक पॉलिनोमियल बन जाएंगे।
वो तो तरीका हम लोग ने शुरू में ही देखा था, वो तो बहुत सॉल्व करना पड़ेगा इक्वेशंस, राइट?
हाँ। और सेकंड तरीका है एक तो मतलब पॉलिनोमियल अलग तरीके से बनाना।
वही तो देखना है, वही तो समझाना है तुम्हें।
हम्म।
फर्स्ट तरीका बहुत लंबा है ना, वो तो हो जाएगा लेकिन उसमें बहुत टाइम लगेगा ना।
यस सर।
सेकंड तरीका समझने की बात है। आंसर तुम्हारा सही है लेकिन तरीका तुमको आता नहीं है, तुम समझा नहीं पा रहे हो। ओके, अब ध्यान से सुनना, फिर से मैं रिपीट नहीं करूंगा। ये अभी अभी समझ लो, उसके बाद फिर खुद से करना होगा, राइट?
यस सर।
The point is, you can see a pattern, clear pattern here, right?
यस।
The pattern is that this 1 and this 5 are adding to 6. Here also 2 plus 4 is 6. 3 plus 3 is 6, right?
यस।
So we can say f of x is equal to 6 minus x. And this is true for which values? X is equal to 1, 2, 3, 4, 5.
यस।
दिख रहा है क्या मैंने लिखा है ये?
यस सर।
It is clearly true for any 1 to 5 values के लिए true है, right?
यस।
Great. तो इसमें ऐसे लिख सकते हैं f of x plus x minus 6 is equal to 0 for x is equal to 1, 2, 3, 4, 5.
यस।
ऐसे लिख सकते हैं।
यस।
ग्रेट। तो हमको पता है कि ये जो चीज है ये 0 हो जाता है फॉर 5 वैल्यूज, राइट?
यस।
लेट्स कॉल इट a new polynomial g of x। किस चीज को? लेफ्ट हैंड साइड को, राइट?
यस।
So we are saying that g of x is 0 for x is equal to 1, 2, 3, 4, 5, right?
यस।
Notice that f of x was degree 5 polynomial और x minus 6 is degree 1। तो जब तुम दो polynomials add करोगे तो final polynomial will be also be degree 5, right?
यस।
Okay, so now we know that g of x is a degree 5 polynomial which is equal to 0 for 5 values, right?
यस।
So obviously 1, 2, 3, 4, 5 are the 5 roots of g of x, right?
यस।
Do you understand what I'm saying?
यस सर।
और f of x का लीडिंग कोएफिशिएंट 1 था, तो g of x का भी लीडिंग कोएफिशिएंट 1 होना चाहिए।
यस।
सो g of x का लीडिंग कोएफिशिएंट 1 है और रूट्स क्या है?
1 2 3 4 5।
कैन वी राइट इट लाइक x minus 1, x minus 2, x minus 3, x minus 4, x minus 5?
यस।
रूट्स पता है ना g of x के?
यस।
तो g of x has been written like this, and now put back g of x का original meaning f of x plus x minus 6, right?
यस।
So you are getting f of x plus x minus 6 is equal to x minus 1, x minus 2 till x minus 5, right? Product. And from
यस।
here we get f of x is equal to x minus 1 till x minus 5 product plus 6 minus x. Do you understand what is involved? What have we have done?
यस सर।
तो ऐसे एक्सप्लेन किया जाता है, ऐसे समझना है कि हमारा f of x पे there was a pattern that was visible. We wrote the pattern for some values of x. Then we brought everything to one side and we have a new thing which is equal to 0 for some values, right?
यस।
That new thing is a new polynomial g of x, right?
Yes.
दिस न्यू पॉलिनोमियल के पांचों रूट्स पता है, तो न्यू पॉलिनोमियल को ऐसे लिख सकते हैं, मतलब
हाँ.
बिकॉज इट्स डिग्री लीडिंग कोएफिशिएंट इज 1 एंड इट्स डिग्री इज 5। जैसे ही तुम
Yes.
न्यू पॉलिनोमियल को ऐसे लिखोगे बस एफ एफ एक्स आ जाएगा फिर, राइट?
Yes.
और नाउ यू कैन पुट इन 6 इनटू इट एंड यू विल गेट 0 फ्रॉम हियर एंड 120 फ्रॉम हियर, करेक्ट?
Yes. Yes.
So what I would say to you is don't try to memorize some method that your sir has shown if you don't understand it.
Yes, sir.
अगर समझ में नहीं आया है तो मेथड मेमोराइजेशन से कोई फायदा नहीं होगा,
Yes.
और समझ में ऐसा आना चाहिए कि किसी और को समझा सको।
Yes, sir.
यू अंडरस्टैंड व्हाट आई एम सेइंग? अगर तुम 9th ग्रेड 10th ग्रेड के बच्चे को समझा नहीं सकते हो तो मतलब तुम्ही को नहीं आता है।
Yes, sir.
सो एनी प्रॉब्लम इन द फ्यूचर ऑल्सो आई डोंट वांट यू टू लाइक जस्ट गेट द आंसर क्विकली। तो पॉइंट ये नहीं है कि जल्दी से आंसर ले आना है, पॉइंट ये है कि तुमको आना चाहिए कैसे हो रहा है, राइट?
Yes, sir.
Okay, I'll give you some problems. These will be homework for the next class. Okay, so try them out and write the problems right now. Okay, so this is question 1. A and B are two sets. A and B are two sets such that n of A is 4. N of A means number of elements of A is 4 and n of B is 5. If the number of possible functions from set A to B is x, if the number of possible functions from set A to B is x, and the number of out of these and out of these y functions are 1 1, y functions are 1 to 1, you have to find out x plus y. समझ में आ रहा है ना क्वेश्चन?
Yes, sir.
Okay, just keep writing the questions. Question 2 is find the range of f of x equals to 2 mod x minus 1 by 3 mod x plus 2. इस फंक्शन का रेंज निकालना है। Question 3 is domain of the function f of x equals 1 by x plus 1 by root over x square minus 4x plus log x. Question 4 is which of the following is an odd function? Which of the following is an odd function? Have you written these 3 questions already?
Yes, sir.
Okay, so I'm going to rub off those. So, which of the following is an odd function? We'll have 4 functions given to you. You have to figure out which one is odd. So I'll write the functions now. Okay, so the first function is f of x is equal to x cube by 2 power mod x plus sec of x, 2 power mod x plus sec of x. The second function is f of x is equal to x power 4 times e to the power root of x square plus 1 plus x power 4 in bracket. The third function is f of x is equal to e power x minus 1 by e power x plus 1 times g of x plus g of minus x. And finally, the fourth function is f of x is equal to h of g of k of x, where h, g, and k are all odd functions. सारे options लिख लिए ना?
Yes, sir.
Here, whenever we are saying we don't know anything about g of x, h, g, k, we just know this much information that these are functions, and here in this option, these are odd, right?
Yes.
Okay, so question number 5 now. Uh, Question 5 is consider three functions f of x is equal to x square minus 4x, g of x is equal to x plus 5, g of x is equal to x plus 5, and h of x is equal to x minus 12. Now, what we have to answer is, first of all, number of integral values which are not in the range of h of g of f of x divided by h of f of x. And second question is, okay, let's not do the second question. Do you know what is an invertible function?
No, sir.
So basically, invertible function means you have to read from your module. Invertible function means one onto type of function. Okay.
Yes.
So if the largest interval of x for which g of x is 1 1 on 2 is taken as a to infinity, and the least value of h of f of x is b. You have to find a plus b. Are you understanding what I'm saying here?
Yes, sir.
Largest interval of x for which g of x is 1, 1 on 2, right?
Yes.
That is given as this, and least value of this is b. You have to find a plus b. Okay.
Yes.
Now, two more questions, I think. So, okay, actually, two, three more questions. Try these out. Question 6 is number of integers. Number of integers in the range of f of x is equal to signum function ln x square minus 2x plus 2. I hope you know what signum function is. We have discussed signum function in the previous class, right?
Yes.
Okay. Then the next one is question 7. Number of solutions, number of integral values of x. Number of integral values of x in the domain of f of x is equal to sine inverse x minus 1 plus log base pi 2 minus x. So here you have to study from your book, and in your book they might have discussed in Allen book that what is the domain of inverse sine function and all. Inverse
Yes, sir.
sine and inverse cos functions. Okay. So
Yes.
go through your textbook and see, and then try to solve this. So these are the 7-8 questions. You need to try it out. And in the next class, we'll discuss these and then we'll do some more problems. Okay.
Yes, sir.
You have written all of them now?
Yes. Sir, the next
Hmm.
class will be tomorrow or when?
Not tomorrow. We'll do it on Monday.
Okay, sir.
Uh, I have this started functions in Allen
Yes, sir. Started.
from when?
Uh, Sir, they are teaching transformation of graphs.
I thought it was starting, your classes were starting on 12th or something. No? It started before
Sir, it
only.
has postponed. It means they are taken that only. First only they are taken.
Hmm. Okay. So make sure that you are doing your Allen module exercises. Okay.
Yes, sir.
Do the exercises, find out if there are any doubts. You can ask those doubts in class. Okay.
Yes, sir.
Fine. So try these questions and then we'll discuss the solutions later. Okay.
Yes.
That's all for now.
Yes.
Bye.